What is up, mathletes? So I was working with a student and we were looking at a review for hypothesis test. And so this is what we did. So in case you're wondering, how do I study? How do I get better at, just understanding these ideas? This is a great practice. I want to walk you through what we did, kind of how we dissected things. Um, because again, doing the homework is not enough, right? We got to put in that work and time, which so many of you guys are doing. All right. So check this out. In our ebook, for those of you that are in my class, and even if you're not in my class, it's the same principles, right? So they usually have like chapter reviews or chapter quizzes. So this is from wherever you're doing hypothesis testing. Okay. And so they have some great questions. And I wanted to kind of take a deeper dive in each one of these to help us really understand what is it that we just did. All right. And so let's look at some of these questions. So this first one's a fill in the blank. So a test of hypothesis H naught mu is equal to 65 versus our alternate hypothesis. Many of you, if you're not in my class or if you're in you might be using H sub A, same thing, right? Our alternate hypothesis. Mu is not equal to 65 was performed. So here we're saying we have a two-tailed test. Here we have a pretty small p-value of 0.035. So basically what happens is you take a sample, right? And you get some, in this case, sample mean. And what this p-value does is it says, hey, what's the probability of observing this, of actually getting this result or something as extreme as this? And so here we're saying, hey, it's pretty rare, right? Getting it's like 3.5% chance of that actually happening, right? So here what we're going to do is we're going to fill in the blank. If mu is 65, right, then the probability of observing a test statistic as extreme or more extreme than the one actually observed is, and so this is it right here, the 0.035, right? And that's what your p-value is. It represents that probability of observing such a test statistic as extreme or more extreme than the one observed. So basically, they don't give us the sample mean, but they're saying, hey, the chance of you actually getting this result, something's up. It's worth looking into, right? Some type of impact is happening or change has occurred. All right. Let's look at number 2. A hypothesis test in a p-value of 0.008. All right. So the test results in a p-value of 0.008, which is the best conclusion. So H naught is definitely false. All right. H naught is definitely true. H naught is plausible. H naught might be true, but is very unlikely. And H naught might be false, but is very unlikely. Notice what they do not give us here. They do not give us an alpha level. So because they don't give us an alpha level, let's think about what this actually means, right? So obviously this is a really small p-value. And remember when we're doing these hypothesis testing, even though we might have strong evidence, that doesn't mean 100% of the time this is what's going on, right? It kind of pushes us to think that way, but that's not always the case. So here, notice if we have such a small p-value, most of the time we reject H naught, right? When we have a really, really small p-value. Depending on what your alpha level is, right? Because these might be fairly close to our alpha level, but this small a p-value usually is smaller than all the alpha levels that we choose. And so typically, right, 99.99% of the time, I haven't seen an alpha level that's smaller than this, but I'm not saying it can't happen. So here we would typically reject H naught. But we can't say it's definitely, H naught is definitely false. What we say is, you know what, H naught might be true, but it is very unlikely for that to be the case. right? So again, and that's why they chose this one right here, number 4. And so again, what we're doing is we're providing really strong support, really strong evidence, but in this statistic hypothesis world, we're never 100% certain, right? But we're pretty darn confident that something's going to happen. All right. And so let's take a look at this next one. Number 3. So true or false? If P is equal to 0.03, the result is statistically significant at the 0.05 level. So remember, what we're choosing here is the reason it's true. We compare P to alpha. Our P is less than alpha, right? Our P is less than alpha. So what that means, from what we've learned, is we reject our null hypothesis, saying, hey, some difference has occurred. And we should go and look to see kind of what's going on here. So there is a statistical significance. All right. If P was greater than alpha, then we would say that would be false. So looking at this same p-value for part B, we're going to see the opposite, right? We're going to see false because our p-value is less, or is greater than, excuse me, our alpha. So yes, it's pretty low, but because we set our alpha level so high, we're saying, right, it's not statistically significant, right? So like what we talked about in class, and I'm sure you talked about your other classes, we don't have enough evidence at this significance level to reject that claim that was made, right? We wanted to show without a reasonable doubt this is going on. So here, what we're doing is we're comparing our p-value to these alpha levels. For this one, it says the null hypothesis is rejected at the 0.05. So remember, we reject it when P is less than alpha. So here we do reject because P is less than alpha. Here, our P, 0.03, is not less than alpha. So that's why this one's false. We would not reject our null hypothesis. All right. So again, here what we're doing is just practicing understanding the conclusions and what does it mean? What do these p-values tell us? Because I remember, and this is in our class and any other class, right? This is where students tend to struggle. And then the hypothesis for number 4, a null hypothesis is rejected at the 0.05 level. All right. So remember, for a null hypothesis to be rejected, right, our rules state that our p-value has to be less than 0.05. So this one's going to be false, right? Because here it's saying the p-value is greater than 0.05. And this one's going to say be true because here it's saying p-value is less than 0.05. So if this is true, p-value is less than 0.05, yeah, we're rejecting our null hypothesis at when alpha is 0.05. Okay, so again, just reiterating, kind of highlighting the fact. And the same thing with the statistically significant. So the result is statistically significant when we reject our null hypothesis. So here, since our the result is statistically significant at the alpha 0.05 level. All right. So notice what they told us to begin with. A null hypothesis is rejected. So when we're rejecting our null hypothesis, we're saying, yeah, it's statistically significant. When here, right, the result is statistically significant at, notice what happened, our alpha level has changed, right, of 0.10. So here, the null hypothesis is rejected at the alpha 0.05 level. So what this means, let's think about this one. What this is telling us, if it's statistically significant, what this implies, this one kind of makes us think a little bit more. Let's write this out. Oops. What this is telling us is that P, if we reject it, P is less than our original alpha. So P is less than 0.05. But now look at this. Now they give us a new alpha, 0.10. So remember, this is the one that we're kind of starting with. So we're knowing P is less than alpha with 0.05. But now we're saying Is this true that it would also be statistically significant if alpha is less than 0.10? Well, if alpha is less than if p is less than 0.5, excuse me, 0.05, then that also means that p is going to be less than 0.10. So this one would be true as well. Because if p is less than 0.05, then which is 5%, then it's going to be p is definitely going to be less than 10%. And I use the word percent because a lot of you, it's easier for you to think of it that way. All right. So again, just some things we talked about earlier in someone wanted some additional help. And so they had some great questions. So I wanted to kind of go over them with you as well. So a sample size of 8 is drawn from a normal population with mean mu, and the population standard deviation is unknown. So notice the population standard deviation is unknown, but our sample size is 8, very small. Here's some good news though. It's drawn from a normal population. So because it's a normal population, right, that tells me, all right, cool, I'm going to be able to use a z-test or a t-test, but then they come and they hit us and they tell us the population standard deviation is unknown. So once they throw that at us, that's how we know we got to go with the t-test because we don't know the population standard deviation. So this would be false. No, because the population standard deviation is unknown. So if they give you the population standard deviation, right, that's what's pointing you in this direction of the z-test. But again, you always want to make sure that all those assumptions are made. Is it appropriate to perform a t-test? All right. So here, boom, yes. And like I said, the population is normal. We would first check to see if the sample size is greater than 30. It's not. So what that means, okay, if it's not, we got to make sure that our population is normal before we conduct this test. Okay. Let's go through this. So again, a lot of, this is a good quiz because it makes you think a little bit before you just go in and start plugging in numbers into your calculator and using a program. It makes you kind of understand what is this a little deeper. What is it that we're doing? All right, a test will be made of H naught mu equals 4 versus H1 mu is greater than 4 using a sample size of 25. So the population standard deviation is unknown. All right. Find the critical value of the test statistic, excuse me, if the significance level is 0.05. All right. So we got to think about some things here. All right. So let's think about some things. So we got a test is made. So this is our null hypothesis. This is our alternate hypothesis. Using the sample size of this, right? The population standard deviation is unknown. Find the critical value of the test statistic if the significance level is 0.05. All right, so make sure you pay extra attention to this. So they're getting this, and a lot of you guys are going to get a number close to this, and you're going to be like, what did I do wrong? All right, and so this is where we got to be careful. And I'm going to make another assumption here that our information came from a normal distribution. All right, so we're going to hit stat. We're going to go to test. And because we do not know the population standard deviation, all right, this is what I see people doing. They'll go and do t-test. And this is where they're going to run into the error, the mistake. And this is where I could see they're not certain of when we use what program, right? These programs are great, but they're only great if we know when to use them. So they're like t-test, and they're like, I'm going to use t-test because the population standard deviation is unknown. Well, that would be a mistake, all right? Because here, they want us to find, underline this, the critical value. So for the critical value, we do not use t-test. So notice, if I jump in here and I try to use a t-test, now let me move my bar here. They want all these pieces of information. but we have this, which is 4. They don't give us X bar. They don't give us our sample mean. They don't give us our sample standard deviation. They don't give us a sample size, right? This is to help, this program t-test gives us our test statistic. So again, make sure you know when to utilize each program, all right? So in this situation, let me go back. You could use a table. In our class, I kind of showed you a different way. Instead of using the table, we did use it in, some of you used it in the program, our Alex program. But we have this cool program right here, second bars, inverse T. And what inverse T is, it wants the area. Notice this is right-tailed because it's greater than. This is a right-tailed test. But what I'm going to do is I'm going to punch in the alpha level they give me. And what this program wants is it wants the area to the left of that critical value. But what I'm going to do, because I know my answer needs to be positive and it's symmetric, this is going to give me a negative answer. I'm just going to make it positive. That's the easiest way to go around that. Comma. Our DF, our degrees of freedom, is 25 minus 1. So remember, you always do n minus 1. So it's going to be 24. And then we punch that in. And so that's where we get this 1.711 right here. All right. And I said some of you will get an answer close to this because you're going to use inverse norm, but that would be incorrect because inverse norm would be when you do know the population standard deviation. In this case, they tell us it's unknown. All right. So again, when you're combing through this, write down everything that they're asking of you. What are they asking you to find? Here, they want you to find the critical value. All right. So here they want you to find the critical value. So now you have two options. In inv z, or I call it inverse norm. In norm, let me show you. Inv norm, I call it inverse norm, good, right? And then inv t, I call it inverse t, right? So those are two options when we want the critical value. So again, make sure you write that down and make yourself like a good kind of cheat sheet or a map of everything, right? Because all these programs, they're going to blend in, they're going to mix together, and it could be confusing, right? Let's do another one. True or false? We could never conclude that H naught is true. All right. So that is true. Right? We're never 100% certain. What the statistics is going to do is it's going to give us like a really strong recommendation. Hey, based on the evidence that you provided, this is what it looks like. Right? But we're never 100% sure. Okay. But this is my strong recommendation. Just like liking this video is going to help other people see it, right? Commenting on this video if it was helpful is going to help other people see it. And so I hope you do that so that other people get the help that they need as well. I hope this is helpful. If it's garbage, don't like it, all right? Don't share it if it's not helpful. In a random sample of 500 people who took their driver's test, 445 people passed. Let P be the proportion who passed. So it's always important you know what P represents. What is it that you're looking at? All right. So P represents, the population proportion who passed. And that's what we're looking at right here. We have a sample. We've got a good idea, but we don't have the population. So a test will be made of H naught to see, is there a difference from P equal to 0.85? In particular, we want to see, did that population proportion increase? Is it bigger than 85%? And look at the sample they gave us, the 445 divided by 500. Let me just show you something real fast. So this is X divided by N. And so our sample mean, right, our P hat, if you will, is 0.89, our sample proportion, 0.89. So what we're going to do here is compute the value of the test statistic. All right, so now we get into our test, which is under stats and test. And we have some options. All right, so our options, we've done z-test, we've done t-test so far, and then we've done one prop z-test. And notice we're dealing with proportions here. We got an x, we have an n, right? We don't have an x bar, we don't have the standard deviation. All right, so always write down everything that you're given and label it. All right, so here to get the test statistic, we're going to use one prop z-test. And then we plug everything in, right? We plug in this, which is 0.85. We plug in our x. Our x we said is 445. Siri just told me I closed my move ring. I have no idea how. I'm sitting here, but I guess I'm doing a really good job because I've closed my move ring. And then we're choosing greater than. Let me just check if my family's here because Toby's gonna bark his butt off, and you guys will hear all this commotion in the background. And then we'll hit calculate. And oops, notice this changed, so I gotta be careful. Be careful. 0.85. Let me hit enter. Okay, cool. Calculate. I want to make sure those values change, or else my answers will look really weird. All right, so the test statistic, notice 2.5, right? 2.5. Bam. Do we reject H naught at alpha's 0.05? So we could compare this to our p-value. Look how small our p-value is, 0.006. So our p-value is less than 0.05. So that's why we do reject H naught. So again, make your cheat sheet, right? Make sure it's helpful. Make sure it's easy for you to understand. So P is less than 0.05. And we want to stay at our conclusion. So at our alpha level of 0.05, we have enough evidence, right, to support the claim that more than 85% of people pass their driver's test. So again, there's no way we could interview or survey everybody. So what we do is we take a sample. Based on that sample, we're going to make an educated, very educated guess, right? Hey, the information we've gathered is pointing us to believe this right here with overwhelming evidence. Could we be wrong? Absolutely, right? But more often than not, it's going to give us some good information. All right, let's do one more. And if you guys want to look at, other ideas, let me know. And I hope this has been helpful. So let's finish with number 9 here. For testing, mu is 3 versus alpha, the alternate hypothesis, mu is less than 3. The p-value of 0.024 is obtained. Pretty low p-value, right? If the significance level alpha is 0.05, notice we are going to reject our null hypothesis, and we're going to go right here. This is what we're going to conclude. So we say, yes, since p-value is less than alpha, boom, that's what you're doing, right? So again, these questions are just making sure you really understand what we're comparing and how these rules work and how to find the appropriate pieces, like our critical values, our test statistics, our p-values, all that good stuff. But what happens, right, if we changed our p-value, or excuse me, our alpha level, our significance level to 0.01, what would we conclude then? Well, in this case, now our p-value, that same p-value, is greater than this alpha. So because our p-value is greater than this alpha, now we would not reject because the p-value is greater than the alpha level, the new alpha level. All right. So what you set your significance level, your 2, is going to be very important, right, in regards to if you're going to be rejecting your null hypothesis or not. All right, mathletes, so that's what I got for you today. Again, make sure you jump on that homework. After you do your homework, start creating these study guides for yourself. Because what this is going to translate to is once you have your career and your goals, this kind of study guide mentality after doing homework or whatnot, it really starts to shape how productive you are in the future, and it gives you such a clean outlook on, you know, your direction of where to go. So for myself, when I go and do these sessions with you guys, I don't just go in there without any game plan, right? There's a lot of this that I'm doing right here live with you that goes on in the background. And so this is what I want to share with you guys. All right, guys, hope you're having a wonderful day. I hope this is helpful. Again, like the video, please, because I want this to spread to more eyes, because a lot of people struggle with this. It's not easy. All right, guys, peace out.